All right, let's come right out of the gate with something that you think is bad news, but it's actually good news. Here's a list of 5 functions, and I'm telling you, you need to memorize the pattern that is their polynomial approximation. So in other words, for e to the x, you should memorize that these are the terms, or this is the pattern of terms that build the polynomial approximation. You don't necessarily have to worry about learning this rule or this summation notation rule, but you should learn this for each and every one of those. You think I'm crazy. By the way, these are also posted in your note packet, so you can take a hard copy look at those. So the question is, why would I make you do this? Or why would I kindly request that you do this? I have an answer for you. Without any exaggeration or hyperbole, I will tell you that it's going to make your math life easier, and I'm going to show you that in the rest of this video. And it will certainly make your AP test grade better, because the AP test writers will use these in several circumstances, and it's going to save you a lot of time and effort and accuracy if you know the approximations by memory. So in an effort to convince you that I'm not crazy, we're going to work with this function, sine of 2x. And the instructions could say build a third degree Maclaurin polynomial. That tells us we're centering at x equals 0. Or the instructions could say find the first 2 non-zero terms of the Maclaurin polynomial. I'll show you how those relate to each other when we get to the end, if you don't already know that. So if I were going to build the polynomial approximation, I know I have to use the magic formula. And to use the magic formula, I know I'm going to have to do some calculations ahead of time. The more organized you are with these calculations, the easier it's going to be to apply them to the magic formula. Now that we're kind of used to these, you probably start to abbreviate how much you show in your organized work ahead of time. For example, this n factorial, I don't necessarily need to make a column for it because I can just apply that as I build my actual polynomial. But you'll notice that this function that we're working with, it has a ninja. And so every time I do the derivative, I've got a ninja, and it's compounding with the previous ninjas as well. So as soon as there's a ninja involved, this part of your work becomes a little bit more tedious. And this is a pretty friendly ninja. If I had something like sine of x squared in there, or sine of square root of x, your derivatives would become very, very messy. You would have some ungodly product rules to take care of. You would not be enjoying your life. Thank you for this friendly ninja. So once I've done my legwork on the chart and I'm feeling comfortable with my memory of the magic formula, I can just take this information and some other stuff and start building term by term. And when I do that, I end up with some zeros that make some of these terms have a value of 0, which is nice. So by the time I'm done, my third degree term my third degree polynomial goes out till I have a third degree term. So that's how I know I can end there. And I do have some 0 terms and I have some non-zero terms. So I can go ahead and turn this into a Taylor polynomial. It's actually a Maclaurin polynomial, or a Taylor polynomial at x equals 0. And there it is down at the bottom. Third degree polynomial. Or if I felt like writing those zeros in there, I can. But earlier in the instructions, when it said possibly find the first 2 non-zero terms, that's the first non-zero term, that's the second non-zero term, and that's another way to say the first 2 non-zero terms. So I've completed the task that I was asked to do, and that's my final answer. So you might wonder why the heck we started off this video talking about memorization. I'm going to get to that in a moment, but I want to take a quick sidetrack and alert you to a little bit of naughtiness. The math lawyers would want to talk about this one. This statement casually seems okay, but it would be very naughty and it would get you some boos from the crowd. Here's the reason. When you just write p of x, you're implying that we're going out to infinity. P of x represents the Taylor polynomial, or the Maclaurin polynomial in this case, but that implies that you're going to do every term out to n equals infinity. Here we decided to only go to n equals 3, so the proper notation is this and not this. So if I did take my p of x and I went out to infinity, you could literally say mathematically that your polynomial approximation is literally equal to f of x, as long as you're willing to go out to infinity. Most of us aren't willing to do that. So using that same logic, if I ever say that the third degree approximation is equal to f of x, that's some naughtiness, because this is just an approximation to f of x. It's not the same or equal to in value as f of x until I go out to infinity. So these are two pretty casual notation mistakes that the math lawyers will jump on you for. So now let's get back to this. Why are we memorizing this? So from here, I would know that sine of x equals this, and I could keep following the pattern out. Well, here's why we're doing it. If you think about what we did earlier in the video, we had to do this work to build this polynomial, and it was the polynomial of sine of 2x. But if I have memorized sine of x, watch how easy it is to get sine of 2x. I take my base polynomial approximation, and instead of saying sine of x, I'm saying sine of 2x. So wherever I see an x, I plug in a 2x. I see an x, I plug in a 2x. I see an x, I plug in a 2x. At this point, I have built my polynomial approximation for sine of 2x. In fact, earlier when we went through all that work, we got the same answer as we did here. They might look different, but let's examine this. If I take 2x to the third power, that ends up being 8x to the third. 8x to the third over 3 factorial, which is a 6. So as long as I've memorized this, then I can jump straight to sine of 2x without going through all the work of building the polynomial. Now you might say, building that polynomial wasn't that bad, and I kind of love it. In fact, I know I love it. Well, we could convince you that you're not always going to love it by going to something a little bit scarier. I'm not positive that these next two count as scarier. I bet this one would be if you tried to do this by hand. But let's take a look at 4 sine of x. The mother function, be careful when you say that, the mother function is sine of x, and I've memorized that. So this is just going to be 4 times the sine of x. So it's 4 times each individual term. Boom, I have it, and I didn't even have to go ahead and go through all those steps. Sine of x squared is the one that would really get you, and we could make that even more complicated, believe me. Well, if I know the mother function, everywhere I see an x, I put in an x squared. You got to be careful there because it's easy to make some exponent mistakes. For example, when I get to this term, x squared goes in for x, which ends up being x squared to the 5th power. Side note, there's times when you can just leave it like this because you're not going to need to do more operations with that polynomial approximation. There's other times that you are going to need to do more work with that, so you might end up simplifying that or changing the way it looks. But here's the deal. You're memorizing these mother functions so that when you're asked to build crazier polynomials, you don't have to go through the polynomial building process. You can simply put this information into the form that you've memorized. So it's virtually a guarantee that the AP will select some of these functions in your test. You're really going to be happy with yourself if you've memorized this. Memorizing, probably not a lot of fun, and not why you're paying the big bucks to attend PHSN, but it will pay off, and my suggestion would be do frequent but short duration memory studyings, and after a while you're going to have it down. And there's some nice patterns there. We'll see you later.